This is problem 4.14 in AOPS Introduction to Number Theory. What is the smallest positive integer n such that the value 7 plus 30n is not a prime number? Okay, so we want the value of 7 plus 30n to be not a prime number. So let's just revise the definition of a prime number. A prime number is basically any number that only has two factors, 1 and itself. So let's say I know that 7 is a prime number because 7 can only be factorized into 1 times 7. Those are the only two factors of 7, 1 and itself. Okay, so now we revise prime numbers. We want to make sure that this is not a prime number. So we want to make sure that this is divisible by something else other than 7 plus 30n and 1. So let's see if it's possible that 30n plus 7 is divisible by 2. So let's see. So I'm going to assume that 2 is a divisor of 7 plus 30n. However, I know that 30n is going to be even because, well, 30 has a factor of 2, so 30 is 2 times 15, and 2 times any number gives you an even number. So 30n is going to be even. 7 is odd. That's common sense. So odd plus even is going to give us an odd number. Okay, so despite the value of n, regardless of the value of n, 7 plus 30n is never going to be divisible by 2. Okay, so this case doesn't work. So how about, let's see if it is divisible by 3. So we know that 30n is divisible by 3 because, well, 30 has a factor of 3 in it. So we have 3 times 10n, which is obviously a multiple of 3, given that n is a positive integer. 7, however, is not a multiple of 3. So we know that if a non-multiple of 3 plus a multiple of 3, so the sum of a multiple of 3 and a not multiple of 3 will give us a number that is not a multiple of 3. So 7 plus 30n can't be divided by 3, despite the fact that we don't know n yet. We already confirmed that 7 plus 30n is not divisible by 3. Let's try 5. So 5 is, so here we have 5. And we know that 30n is once again divisible by 5 because 30 is just 5 times 6. So 30n is essentially just 5 times 6n. 6n is an integer and 5 is an integer. So 30n is a multiple of 5. Okay, and we have 7. So 5 is not divisible by 7. So the same thing as above, we know that the sum of these two is not a multiple of 7. It's not a multiple of 5. So 5 doesn't work. So how about we try 7 now? So we try 7. So is 7 divisible by 7 plus 30n? So can we prove that it's not divisible? So we know that 7 is divisible by 7, and 7 might divide 30n and might not, because 30 doesn't have a factor of 7, so it depends on the n. If n has a factor of 7, then 30n is divisible by 7. Then the sum of two numbers which are divisible by 7 will be a multiple of 7, which might give us our answer to n. So in what cases does 30n? So in what cases is 7 a divisor of 30? The divisor of 30n? So we want n to have a factor of 7. And we want the smallest positive integer value of n because that's what's requested in the question. So let's just let n be equal to 7. So when n is equal to 7, 30n is 210, which is divisible by 7. 210 over 7 is 30. Okay, so we know that we have, so when n is 7, 7 plus 30n gives us 217. So 217 is divisible by 7, so n equals 7 is a solution for having a not prime number of 7 plus 30n. However, is it the smallest possible value for n? Because when I answered this and I checked my answer, this is wrong. it's not the smallest possible value of n. Okay, so assuming we don't know if it is the smallest possible value of n or not, let's try and check the numbers before n equals 7. So let's say we have n equals 6. Then this gives us, so you have to always check even if you feel like you're 100% sure you found a solution. So you have 7 plus 30n. When n is 6, 7 plus 30n is 187. Okay, so 187 looks like it's prime. It's not divisible by 2, 3, or 5, or 7. So is it divisible by 11 then? 11 is the next prime. We should try that before confirming. And it turns out, yes, 187 is divisible by 11. It's 11 times 17. Okay, so n equals 6 is our next smallest value. So what about n equals 5? What if n equals 5 works? So let's try n equals 5. So when n is equal to 5, we have 7 plus 30n, which is equal to 157. So 157 also looks prime. Let's just confirm. It's not divisible by 2, 3, 5. Is it divisible by 7? No. It's not divisible by 11. It's not divisible by 13. So I'm just doing my math. I'm just doing the math in my head here. So it's not divisible by 17, and we know that 17 is already larger than root 157, so 157 is prime. So n equals 5 doesn't work. How about we try n equals 4? Okay, so when n equals 4, 7 plus 30n is 127. So 127 is a prime. I'm just going to tell you that. It's not divisible by 2, 3, 5, 7, or 11, so it's a prime. So let's try n equals 3, 2, and 1. When n is 3, 7 plus 30n gives us 97. That is a prime. When n equals 2, 7 plus 30n gives us 67. So that is also a prime. Now when n equals 1, 7 plus 30n is 37, which is also a prime. So all these values below n equals 6 don't work. So our smallest answer for n is going to be n equals 6. So our answer here is n equals 6, not n equals 7. So in this problem, the key is to firstly realize how we can start finding the solution by checking that 5, 2, and 3 are not potential divisors of 7 plus 30n at all, and we skip to 7, and we find out n equals 7 works. And the second part is to figure out that n equals 7 is not actually the smallest positive integer value of n, and you have to make sure you check values below 7 for n. So thanks for watching.